The first burst sounded wrong. Corporal David Chen had been firing M1919 Brownings for 11 months, knew the rhythm of the weapon like his own heartbeat. But this was different. Each round didn't just punch through the jungle, it detonated. Sharp cracks rolled across the hillside as palm trunks exploded into splinters, and the Japanese bunker he was targeting simply disintegrated from the inside out. Logs that had absorbed 1,000 rounds of standard ammunition a day before were now fragmenting like kindling, throwing smoke and fire into the morning air. Chen lifted his head from the weapon, hands still gripping the spade grips, and watched as a fortification that had killed 3 men in his squad collapsed into a smoking crater. His assistant gunner, Private Billy McKenna, stared at the ammunition belt feeding into the receiver, then at Chen, then back at the belt. Neither man spoke for a long moment. Finally, McKenna whispered, "What the hell did we just fire?" Chen had no answer, only the ringing in his ears and the smell of something burning that wasn't just gunpowder. If you believe innovations like this deserve to be remembered, subscribe now. These are the weapons that changed everything, and the stories behind them need to be told. The M1919 Browning machine gun had been designed in 1919 as a refinement of John Browning's earlier water-cooled M1917, adapted for mobility and sustained fire without the weight penalty of a cooling jacket. By 1943, it was a standard medium machine gun of American forces, firing the .30-06 Springfield cartridge at a cyclic rate between 400 and 600 rounds per minute depending on condition and variant. It was a weapon of suppression, designed to force enemy troops into cover while friendly infantry maneuvered, to deny ground and control space through volume of fire rather than precision. The doctrine was straightforward. Establish a base of fire, pour rounds into enemy positions, keep heads down, allow your riflemen to close and destroy. In the open terrain of North Africa or the hedgerows of France, this worked. In the Pacific, where Japanese defenders built fortifications deep in jungles so dense that visibility was measured in yards, where bunkers of logs and coral rock could absorb thousands of rounds without failing, suppressive fire alone was inadequate. American casualties mounted as infantry tried to close with positions they couldn't effectively engage at range. Flamethrowers worked but required operators to approach within 50 feet, crossing ground covered by interlocking machine gun fire. Demolition charges were effective but demanded even closer approach. Artillery and air support were often unavailable in terrain, where coordinates were approximations and friendly forces were dangerously close to targets. The tactical problem was simple. How do you destroy a fortification without getting killed trying to reach it? The answer came from ordnance engineers who understood that the .30-06 cartridge, while designed to conventional ball ammunition, had just enough internal volume to accommodate an explosive charge if the bullet was redesigned. The concept of explosive small arms ammunition wasn't new. European nations had experimented with it during World War I, and both British and German forces had developed limited production rounds for specialized purposes. But the engineering challenges were formidable. A bullet experiences acceleration exceeding 40,000 times the force of gravity when fired, creating stresses that would detonate most explosives prematurely. The fuse mechanism had to survive this violence, remain stable during flight, then function reliably on impact with targets ranging from soft tissue to hardwood to sandbags. Early American attempts in 1942 resulted in catastrophic failures, rounds detonating inside barrels, killing test crews, or failing to detonate at all. The breakthrough came from engineers at Frankfurt Arsenal in Philadelphia, who developed a setback-armed fuse using principles borrowed from artillery design, but miniaturized to fit inside a bullet barely larger than a pencil eraser. The mechanism was elegantly simple. A tiny steel ball held against percussion cap by a thin copper disc. During firing, the acceleration forced the ball forward away from the cap. On impact, inertia drove the ball backward to the copper disc into the cap, which detonated the main explosive charge. The entire fuse assembly weighed less than a gram and was no larger than a grain of rice. By early 1943, production had begun on what was officially designated the M1 Incendiary cartridge, though this was something of a misnomer. While some variants used incendiary compounds designed to ignite fuel and ammunition, others carried actual high-explosive fillers like tetrol or PTN. The The distinction was partly semantic and partly legal. Incendiary ammunition occupied less controversial territory under international law than explosive bullets. The Hague Conventions of 1899 and 1907 prohibited projectiles designed to expand or flatten in the human body, a rule intended to prevent unnecessary suffering. Explosive rounds existed in a gray area. If their stated purpose was destroying material, bunkers, equipment, supplies, then their use could be justified even if they also killed personnel. This legal fiction satisfied military lawyers and allowed production to proceed, though everyone involved understood that a round fired at a bunker occupied by soldiers was being used against both material and personnel simultaneously. The first shipments reached Pacific Theater depots in mid-1943, marked with red bands and warning labels that classified them as experimental ammunition for evaluation purposes only. This designation gave the Army plausible deniability. Officially, the rounds were undergoing field testing, not combat deployment. In practice, commanders distributed them to units in contact, and experimental classification was ignored by everyone from supply sergeants to division commanders. The first documented combat use occurred in November 1943 during operations on Bougainville, though the after-action reports are deliberately vague about specifics. A Marine weapons platoon engaged Japanese fortifications that had resisted 2 days of conventional attack, causing significant casualties and stalling the advance. The platoon sergeant, whose name was redacted from official records, had received a shipment of explosive ammunition and made the decision to employ it without authorization. He personally supervised the loading of belts, mixing 1 explosive round for every 3 standard ball rounds, and positioned his M1919 teams at ranges between 250 and 350 yards from the target bunkers. The engagement began at approximately 1,430 hours and lasted 18 minutes. The effect was immediately apparent. Where standard ammunition had scarred logs and torn sandbags without destroying positions, the explosive rounds detonated on impact, each one a miniature grenade that blew apart cover from within. The first bunker was destroyed within 90 seconds, its log construction shattered by sequential detonations that created structural failure. Defenders attempting to evacuate were engaged by rifle fire. The second and third bunkers fell in similar fashion, and by 1450 hours the entire defensive line had collapsed. Marine infantry advanced and secured the positions without further casualties. The cost in ammunition, approximately 1,100 rounds of mixed load and 2 barrel changes due to overheating. The platoon sergeant received a commendation for tactical initiative and a formal reprimand for unauthorized use of experimental equipment. The commendation went into his service record. The reprimand was filed and forgotten. Word of the explosive ammunition's effectiveness spread through unofficial channels faster than any formal communication could have traveled. Frontline units began requesting it specifically, often through supply sergeants who traded favors, liquor, and captured equipment to obtain cans of the precious rounds. Officially, the ammunition remained experimental and restricted. Unofficially, it became standard issue for any unit expecting heavy contact or engaged in bunker reduction operations. The psychological impact on Japanese defenders was immediate and profound. Early encounters produced confused intelligence reports. Some thought the Americans had developed portable artillery. Others believed it was a new type of flamethrower. When the reality became clear that standard machine guns were now firing ammunition that exploded on impact, the psychological damage was worse than if it had been a completely new weapon system. The machine gun was ubiquitous, appearing at every level of American tactical organization. The idea that any M1919 might be loaded with explosive ammunition meant every machine gun became an object of terror. Japanese soldiers began calling it Kaminari no Kakai, the Thunder Machine, a name that appears in captured diaries, intercepted communications, and prisoner interrogations. The name referred both to the sound, that rolling thunder of sequential detonations, and the almost supernatural destructiveness of a weapon that could tear apart fortifications that had withstood conventional fire. But the weapon terrified its users almost as much as its targets. Explosive ammunition was inherently unstable by design. The fuse had to be sensitive enough to function reliably, but robust enough to survive firing. This contradiction meant that every round represented a calculated risk: barrel obstructions, carbon fouling. Even minor damage to the round itself could cause premature detonation. When an explosive round detonated inside a weapon, the M1919's barrel would rupture catastrophically. The barrel was designed to contain the pressure of burning propellant, approximately 50,000 pounds per square inch, but could not contain the detonation of high explosive, which generated pressures an order of magnitude higher. The result was barrel failure that sent steel fragments into the gunner's face and chest at velocity sufficient to cause fatal wounds. The receiver would crack or warp, destroying the weapon. If the detonation occurred while a belt was feeding, sympathetic detonation of adjacent rounds could turn the entire ammunition supply into a fragmentation grenade. There were incidents carefully documented in ordnance reports, but rarely mentioned in official casualty statistics. On Peleliu in September 1944, Private First Class Daniel Ortega was killed when his M1919 suffered a chamber detonation during fire against a Japanese pillbox. The barrel split longitudinally and a fragment severed his carotid artery. He bled out in under 2 minutes despite immediate medical response. Examination of the weapon revealed a hairline crack in the chamber that had likely existed for several days, slowly propagating with each round fired until catastrophic failure occurred. Ortega had fired over 3,000 rounds through that weapon in the preceding week, including hundreds of explosive rounds. The official report classified his death as combat-related, attributing it to enemy action, because acknowledging that American soldiers were being killed by their own ammunition would raise questions that no one in the command structure wanted to answer. Gunners developed rituals around loading and firing explosive ammunition, semi-superstitious behaviors that gave them the illusion of control over an inherently dangerous process. Some insisted on personally inspecting every round before loading, looking for dents, corrosion, or any sign of damage. Others developed specific loading patterns: one explosive for ball, one tracer. Repeat, believing certain ratios were safer or more effective despite no data supporting these beliefs. Crews positioned weapons behind maximum available cover, sometimes building sandbag walls 3 feet high around gun positions, as much to protect themselves from their own weapon as from enemy fire. They wore extra protective equipment: goggles, heavy gloves, additional padding on shoulders and chest. They rotated barrels more frequently than maintenance schedules required, knowing that barrel were accelerated dramatically when firing explosive rounds due to the additional stress of detonation back pressure. Some gunners embraced the danger, became known in their units as Thundermen, volunteered for any fire mission regardless of risk. Others requested transfers, citing equipment problems or medical issues, anything to escape assignment to weapons that could kill them without warning. There was no middle ground between acceptance and rejection of the role. The tactical advantages, however, were undeniable enough that the risks were accepted at every level of command. Explosive ammunition transformed the M1919 from a suppressive weapon into a multipurpose tool capable of engaging fortifications, light vehicles, ammunition dumps, and area targets with devastating effectiveness. A skilled gunner could just fire based on target characteristics, using short bursts of explosive rounds to destroy cover, then switching to sustained fire with ball ammunition to engage exposed personnel. In the dense jungle environment where most Pacific combat occurred, the ability to destroy vegetation and wooden structures with direct fire created tactical options that hadn't existed before. Japanese snipers, a persistent and deadly threat, found that their carefully camouflaged positions offered no protection against a weapon that could shred a tree trunk in seconds. Bunkers that had required engineers with flamethrowers and demolition charges could now be reduced by machine gun fire alone, eliminating the need for vulnerable close assault. The sound itself became a weapon. That rolling thunder detonation signaled to everyone within earshot that an American assault was beginning, and Japanese defenders often abandoned positions to the sound even when the fire wasn't directed at their specific location. American commanders exploited the psychological effect ruthlessly, sometimes firing explosive rounds at the start of operations just to create panic, then conserving the expensive ammunition by switching to standard loads once the fear effect had been achieved. The Battle of Peleliu in September and October 1944 became the largest test of explosive ammunition under sustained combat conditions. The island was a fortress, over 500 reinforced positions, and caves connected by tunnels, defended by approximately 11,000 Japanese troops with orders to inflict maximum casualties rather than hold ground. The 1st Marine Division assaulted on September 15th and immediately encountered defenses that rendered conventional tactics obsolete. In the first 48 hours, over 1,000 Marines were killed or wounded, and the advance stalled against fortifications that absorbed everything from naval gunfire to aerial bombardment without collapsing. Machine gun teams equipped with explosive ammunition found themselves in constant demand, shifting from position to position, as infantry identified strong points that blocked further advance. The weapons ran nearly continuously, firing tens of thousands of rounds, barrels changed every few hundred rounds, ammunition resupplied by working parties that moved through mortar fire to keep the guns operational. The thunder of explosive rounds became the soundtrack of battle, a constant rolling detonation punctuated by secondary explosions as Japanese ammunition stores cooked off. But Peleliu also revealed the limitations of the thunder machine. Japanese defenders adapted by abandoning surface positions for deep caves carved into coral limestone, positions that even explosive ammunition couldn't penetrate. The battle devolved into a cave-clearing nightmare that took 2 months and cost over 10,000 American casualties before organized resistance ended. Explosive ammunition proved invaluable against surface fortifications, but was helpless against positions protected by meters of solid rock. One of the few detailed first-hand accounts comes from Corporal James Mackenzie, a machine gunner with the 1st Marines who kept an unauthorized diary throughout Peleliu. His entry from September 22, 1944 reads, "Change barrels 3 times today. Fired close to 3,000 rounds, at least half explosive. The gun is holding together, but I can feel it getting worse. Every time I press the trigger, I think this is it. This is the burst that blows the chamber and kills me. But it keeps working. We hit a bunker complex this afternoon. Big position with maybe 20 Japs inside. Good interlocking fields covering the approaches. Tommy wanted to call up engineers with satchel charges, but Lieutenant said no. We lose too many men getting close. He told us to use the thunder. So we did. First burst hit their firing slit. Saw the flashes inside as the rounds detonated. Second burst, I walked up the front face, blowing apart the log construction. Then the whole thing collapsed inward like something had pulled it from inside. We didn't find bodies when we cleared it later. Found pieces, parts, things that used to be men but weren't anymore. I can't describe it better than that. Tonight I couldn't eat, couldn't sleep. Just kept seeing those pieces and thinking about the moment when they were still people, still human, before the thunder turned them into objects. They were trying to kill us. I understand that, accept it even, but the way they died wasn't right, wasn't clean, and I did that. I made that happen. The psychological and ethical questions surrounding explosive ammunition were never formally resolved, either during the war or afterward. Military legal advisors constructed arguments that the rounds were legitimate anti-material munitions, their use against personnel being incidental to their primary purpose of destroying fortifications and equipment. Critics pointed out that a weapon system employed primarily to kill human beings should be evaluated based on actual use rather than stated intent, and that explosive bullets violated the spirit, if not the letter of international agreements, prohibiting weapons designed to cause unnecessary suffering. The debate remained theoretical because no formal challenges materialized. Japan, facing strategic defeat by 1945, filed no diplomatic protests about American ammunition. After the war, with Japan occupied and its government focused on survival rather than legal recriminations, the subject was quietly dropped. The Nuremberg and Tokyo war crimes tribunals examined atrocities and systematic violations of the laws of war, but didn't address tactical weapons choices. Explosive small arms ammunition fell through the gap between legal categories, neither explicitly prohibited nor clearly permitted, a weapon that existed because it was effective and because no one with authority chose to forbid it. Production of explosive ammunition peaked in early 1945 at over 50,000 rounds per day, driven by planning for Operation Downfall, the proposed invasion of Japan scheduled for November 1945. Planners anticipated that Japanese defenders would employ the same deep fortification tactics that had made Iwo Jima and Okinawa so costly, and explosive ammunition was considered essential for reducing the thousands of bunkers and fighting positions expected along invasion beaches. Millions of rounds were manufactured and stockpiled at staging areas throughout the Pacific, ready for the largest amphibious operation in history. The atomic bombings of Hiroshima and Nagasaki in August 1945, followed by Japan's surrender, made Operation Downfall unnecessary and simultaneously made the explosive ammunition stockpiles obsolete. Within weeks of the surrender, production contracts were canceled and manufacturing facilities were retooled for peacetime production or mothballed. The sudden end left the military with millions of rounds of ammunition that was too dangerous for long-term storage, too expensive to maintain, and too politically sensitive to acknowledge publicly. The post-war disposal of explosive ammunition became a bureaucratic and logistical challenge. The rounds were sensitive to temperature variations, humidity, and physical shock, making long-term storage impractical. Chemical degradation of both the explosive filler and the fused components meant that ammunition manufactured in 1943 or 1944 will become increasingly unreliable with each passing year. Some stockpiles were used for training purposes, fired under controlled conditions to demonstrate the ammunition's effect to officers and NCOs who would form the core of the post-war military. Most was consolidated at Aberdeen Proving Ground in Maryland, where it sat in storage bunkers through the late 1940s, while officials debated final disposition. The Korean War, beginning in June 1950, created sudden demand for all types of ammunition and briefly revived interest in explosive rounds. Testing revealed that storage conditions and chemical degradation had rendered the ammunition dangerously unreliable. Failure rates exceeded 50%. More than half the rounds either failed to detonate or detonated prematurely in the weapon. Several test weapons were destroyed, and 2 crew members injured before the testing program was terminated. The decision was made to destroy the entire remaining inventory. Through the summer of 1950, controlled demolitions at Aberdeen eliminated over 2 million rounds in a series of detonations that observers reported could be heard for miles, a continuous rolling thunder that echoed across the proving ground for days. It was an appropriate end for ammunition that had been named for the sound it made. The M1919 Browning served through Korea and into Vietnam, remaining in American service until the 1960s, but never again fired explosive ammunition. The institutional knowledge required to develop, manufacture, and safely employ the rounds faded as engineers retired, ordnance specialists moved to other programs, and a specific combination of tactical necessity and industrial capacity that had created the thunder machine never recurred. Modern explosive ammunition exists, used in specialized roles like anti-material rifles firing .50 BMG or 20 mm rounds, and in vehicle-mounted automatic cannons. But these are different weapons firing different ammunition under different tactical doctrines. Nothing quite like the World War II explosive machine gun ammunition has been produced since, perhaps because the lessons learned about effectiveness and risk, about tactical advantage and human cost, about weapons that terrify everyone involved, were absorbed and filed away as something that worked but should not be repeated. The legacy of the Thunder Machine exists primarily in archives and memories, in the classified ordnance reports and after-action summaries that document its development and use without celebrating it. The veterans who used it rarely spoke about the experience, and when they did, it was often with ambivalence that mixed pride in having wielded an effective weapon with discomfort at what that effectiveness entailed. They had saved American lives by destroying enemy positions without requiring close assault. They had also killed in ways that reduced human beings to forensic puzzles, that turned fortifications into abattoirs, that left psychological scars on both users and survivors. One veteran, interviewed in the 1990s for an oral history project, described the experience this way. They told us it was experimental, that we had to be careful, that the gun could blow up, and it could. I saw it happen to other crews. But when you're looking at a hillside full of bunkers, and you know men are going to die taking that ground, you don't think about experimental. You don't think about danger to yourself. You load the belt, you aim, you fire, and you hope the gun holds together long enough to do the job. Most times it did. Most times. And when it worked, when you watched those bunkers just disintegrate, when you saw the enemy running or not running anymore, you felt powerful. You felt like you had the power of God. And that feeling scared me more than the enemy ever did, because I liked it. For those few seconds when I was firing, I liked having that power. And later, when I had time to think about what that power had done, what it had turned men into, I hated myself for liking it. The Japanese soldiers who survived encounters with explosive machine gun ammunition carried their own scars, psychological damage that lasted decades after the war ended. Post-war interviews conducted by historians include recurring descriptions of the Thunder Machine, often with mixture of residual fear and reluctant respect for American industrial capacity and tactical innovation. One former Imperial Army sergeant, interviewed in the 1980s, described an engagement on Luzon in January 1945. We had prepared positions for 3 months, good construction, logs, and earth meter stick, fire in positions that covered all approaches. We had survived American artillery and mortar fire for days. Then the thunder began. At first we thought it was artillery, but there was no whistling of shells, no delay between sound and impact, just explosion after explosion, so fast they sounded like one continuous roar. The logs above us shattered. Earth fell from the roof. Men were screaming, not from wounds but from fear, because we couldn't understand what was happening. We couldn't fight against something we couldn't comprehend. When the order came to abandon the position and retreat, we ran. And the thunder followed us down the hill, those explosions chasing us like something alive. I don't know how I survived. I don't know why the bullets missed me when they killed the men beside me. I only know I never heard that sound again, and I pray I never do. For years afterward, I would hear thunder during storms and be back in that bunker, feeling the walls collapse around me. The Thunder Machine faded from history not because it failed, but because it succeeded too well, revealing truths about modern warfare that neither military establishments nor societies were comfortable acknowledging. It demonstrated that innovation in weapons technology is driven by desperation and measured by effectiveness rather than ethics, that the line between legitimate tactical weapons and instruments of unnecessary suffering is thinner than international law pretends, and that the psychological cost of wielding extreme violence falls on users as well as victims. The explosive rounds accomplished their purpose. They destroyed fortifications, killed enemy soldiers, saved American lives by reducing the need for close assault. They also created a weapon system so terrifying that even the men who depended on it were relieved when it was retired. There are no monuments to the Thunder Machine, no museum exhibits dedicated to explosive .30-06 ammunition, no official histories that examine its development and use in detail. The weapons were scrapped or sold as surplus, the ammunition destroyed, the documentation filed in archives that few researchers access. The only memorial exists in the memories of men who heard it, fired it, or died under it. And those memories are fading now as the last generation with direct experience of World War II passes. If this story gave you a glimpse into weapons and innovations you never knew existed, subscribe now. There are countless more stories buried in history, waiting to be told. Let's make sure they're not forgotten. The M1919 Browning continued to serve for decades after World War II, but its brief transformation into the Thunder Machine remains a footnote in its history, a chapter that manufacturers and military historians rarely emphasize. Perhaps because it represents something uncomfortable about how wars are actually fought, about the gap between the sanitized narratives of tactical innovation and the messy reality of weapons that kill indiscriminately and terrify indiscriminately. The thunder that rolled across Pacific jungles for 2 years was the sound of industrial warfare stripped to its essence, of killing made efficient through engineering, of men doing what was necessary and carrying the weight of that necessity for the rest of their lives. That sound has faded into silence now, but for those who heard it on either side of the weapon, the echo never completely disappeared. And maybe that's the real legacy of the Thunder Machine. Not the battles it won or the lives it saved or took, but the reminder that every innovation in warfare carries a human cost that can't be calculated in after-action reports or measured in rounds expended. The cost is carried in memories and nightmares, in the knowledge of what humans are capable of doing to each other when necessity and technology align, in the understanding that some victories are won with weapons we're relieved to retire when the fighting ends.